Today's video is about making a frame for my CNC electronics. Hi, welcome to Slow Engineering. I'm David. Last video I showed the CNC electronics and wiring. Before powering them up, I plan to build a frame for them. Learn from Voron design and other industrial applications that use DIN rails to fix electronics to walls or boxes. DIN rails are designed to mount various electronic modules. For firmware testing purposes, the boards on the DIN rails require easy access to refresh the firmware. If the frame is also portable, it would be a convenient solution. I only need to enclose this portable frame to prevent direct contact with these electronics later when all firmware settings are tuned. Starting with the design, I need a frame with several DIN rails. I searched for materials in my workshop and found a 1 meter long, 6 mm outer diameter stainless steel tube, combined with some 3D printed corners and mounts for the DIN rails. It should support all the electronics. The 1 meter stainless steel tube is cut into 12 16 mm tubes for the upper frame and two 127.36 mm tubes for the bottom connection. This design would be a pair of triangle stands with DIN rails to form the structure. For the printed frame parts, ensure the holes are tight for the tube's outer diameter. Additionally, DIN rail support parts require threaded inserts for mounting. Now start assembling. The tight tolerance holes requires extra force to push the tubes into the parts. It would be helpful to have a flat surface to align the printed DIN rails mounting parts. After finishing the first triangle stand, repeat the same steps to build another one. The next step begins with the power supply and the power switch. The power supply itself has mounting threads for assembly. Utilize these threads with a bracket to fix them to the DIN rails. This custom bracket across two parallel DIN rails to achieve a stable mount. For the clampers, I used the DIN rails clampers from Voron design. The original clamper design is for M2 self-taping screws. So I made some changes to enlarge these holes to fit regular M2 screws and install 4 clampers onto the bracket. After the clampers are installed, place and secure the power supply onto the bracket with 4 screws to finish the power supply module. For the power switch, I create a panel to isolate the pins behind the switch to avoid shock. The switch will be placed in the center of the panel to avoid interference with the DIN rails. Install 4 clampers on the panel's backside. Then insert the switch into the mounting holes and tighten it to finish the switch module. Lastly, there are the control boards which also share the same way to install brackets and clampers. When all the modules are ready, it's time to put them together and make a frame. Start with the power supply unit. This unit is the only module that stays alone on the side. Others will share the space to perform as an access side. Insert the DIN rails into the clampers by pulling the clamper jaws. The finish will have 2 rails in parallel at the back of the power supply. It's the same method to prepare the power switch panel. After finishing the rails assembly, slide the power supplies to one side for DIN rails installations on the triangle stand. Align the DIN rails to the stand mounting holes and tighten them together. Repeat the same procedures for the other side. The frame should have a stable stand when two sides are connected. In the remaining space, grab all modules for quick installation. Remember to consider the wire paths and board orientation. Replug all the connectors back into the modules and manage the cables. Use the space between two sides to hide extra cables. This is the portable DIN rail frame design and assembly. I hope you enjoyed. If you have any suggestions about this CNC project, please comment below. Like, share this video, and subscribe to this channel if you think it's helpful. Or consider becoming a Patreon member to support more projects. Thank you for watching, and see you next time.